is if you were going to look at the meshes that you would draw, if you look at the meshes that you draw, so I have one here and one here. On the shared branch is a current source. When your shared branch is a current source, with or without a resistor, doesn't matter if it has a resistor, then you can use a super mesh. And what that means is when I set up my equation, I'm just going to have one equation for both of these meshes together. So I also have that mesh up there. But hold on just a second. All right, so I'll call this one I1, and this one I2, and this one I3. And I'll set up my mesh equations, but when I do, this middle branch would cause me a problem with the I1 and the I2 because I wouldn't know how to do the voltage drop. Notice R, we don't even know what R is in this problem. It's just R. But we can solve the problem even without knowing what R is. And so we're going to do this as one big mesh, and then we're going to relate the two currents with this middle branch. So I'll start over here. So going through the 1 kilo ohm resistor, that's 1K times I1. And then I've got this 4 kilo ohm resistor, but that's being shared with I1 and I3. So that's 4K times I1 minus I3. And then I'm going around over to, I get to the 6 kilo ohm, so I have plus 6K times, now it's I2, that's going in that direction, I2 minus I3, plus, and then 4K times I2 equals 0.
So what does the K stand for?
Kilo, 1,000. So rather than, see how these are all kilo ohms? Rather than writing 1,000 each time, I'm just writing K.
Okay.
And not only that, I'm now going to divide everything by 1,000, and my K's will go away. So I'll just go ahead and do that. I'll have I1 plus 4I1 minus 4I3 plus 6I2 minus 6I3 plus 4I2 equals 0. And since I'm already simplifying, I'll go ahead and do some more here. So I've got 5I1 plus 10I2 minus 10I3 equals 0. Okay, now I'll do my top mesh. So at the top, it's just I3. So that's 2K I3 plus, and as I come around, I've got 6K, and I've got I3 minus I2, and then continuing around plus 4K times I3 minus I1 equals 0. Again, I can divide through by 1,000 and all those K's go away. So I have 2I3 plus 6I3 minus 6I2 plus 4I3 minus 4I1 equals 0. So minus 4I1 minus 6I2 plus 12I3 equals 0. And then, just like I said, I'm really bad at arithmetic, so the smaller the numbers are, the better chance I have of getting it right. So if I divide everything by 2, minus 2I1 minus 3I2 plus 6I3 equals 0. So I have this equation and I have this equation. I have 3 unknowns though and 2 equations, and that's where I'm going to use this middle branch. So this middle branch is 2 milliamps, and we have I1 going this way and I2 going that way. Now the resistor and the current source are in series, so they have to have the same current. And so that means that the sum of I2 and I1 has to be 2 milliamps. I2 is going in the same direction as the current source, and I1 is going in the other direction. And so I can say that I2 minus I1 equals 0.002 amps.
I feel like Sherry just talked about what when that happens. Was that today? Or no? Like when she talked about depending on which one's going the same direction as the current source, that's the one to subtract.
I think we talked about it before within the past week.
It felt like a very recent thing. Yeah, maybe it was Wednesday.
So, because I2 is going in the same direction as 2, that's why you said it's positive?
Mm-hmm. So I'm just saying that
Couldn't be I1 minus I2, that wouldn't work.
well, then if I say I1 now this is my third equation. If I wanted to write it as a 2 instead of a 0.002, that would be fine. It would just mean my units were milliamps instead of amps. And so I would have minus I1 plus I2 plus 0 I3. I'll just go ahead and write it as 2, and now my units are milliamps because I didn't have any other currents already in here. And so now I have my 3 equations, and you've seen me solve equations, so we don't need to do this again. And if you solve these, you get I1 equals minus 1.5, I2 equals 0.5, and I3 equals minus 0.25. And since I used 2 here, these units are all milliamps.
Do you know the format of the test?
Yes, she told me. Okay, yeah, no, I didn't finish. It said to determine Vx. So Vx, what is Vx? Vx is the voltage across this 1 kilo ohm resistor. So if I take the current going from the minus side to the plus side, then that's my Vx that I want there. So Vx equals IR, and I1 was the current going in that direction. Now I do have to pay attention to the milliamps and kilo ohms and all that. So I1 was negative 1.5 times 1 kilo ohm of negative 1.5 milliamps. So milli is times 10 to the negative third, and kilo is times 10 to the third. So those cancel each other out. So that's minus 1.5 volts.
It seems pretty simple, depending on